Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 6 Learning Target 3. Today we are talking about how we graph exponential functions. So an exponential function is any sort of equation that has our variable x in the exponent. So the standard form of an exponential function looks like this, where you have y equals a times b raised to the x power. So this is our variable. The a is going to be some sort of coefficient. Sometimes there is an a, sometimes there's not. And then the b is the multiplier. The b is the base that is being multiplied repeatedly. So b has to be greater than 0, and b cannot be 1, because 1 raised to any power stays 1. So our b can be a decimal between 0 and 1, and then it can be greater than 1. But those are kind of its qualifications. All right, so let's take a look at number 1. If you don't have your calculator out, now is a good time to grab it. I'm going to grab mine as well. You're going to want your calculator when you're calculating all these powers today. Okay, so the first thing here is we are trying to graph this equation. We want to take y equals 4 raised to the x power, or they say y equals 4 to the x, and we want to put it on a graph. The way I'm going to do that is I'm going to make a table of values. In my table of values, I typically make the same x values every time. I go -2, -1, 0, 1, 2, and 3. You'll see those vary. Sometimes people go -1 up to 4. Sometimes people go 0 to 5. It doesn't really matter. The reason I go out to -2 and go up to +3 is because I like to see things on both sides of 0. I want to see some negative values and I want to see some positive values. Okay, so now I'm going to take all of those x values and I'm going to plug them into my equation. When I plug them into my equation, I'm going to use my calculator and I type it in like this. I have 4 and then a caret key and then a -2 and then the enter. So I want you to look for that caret key on your calculator. It should be somewhere over on the right-hand side, the very right-hand side of your calculator. So if I type that in, I've got 4, caret key, -2, and then I hit enter, I get 0.0625 for a value there. Really close to 0. Very, very small number. Then I have 4 raised to the -1st power. That's 0.25. 4 raised to the 1st is going to be 4. I'm sorry, 4 raised to the 0 is going to be 1. And then 4 raised to the 1st is going to be 4. 4 squared is 16. And 4 raised to the 3rd is 64. So you can see that these things grow rather quickly. It doesn't take long for us to be up way off our coordinate plane. I'm not going to be able to graph 364, but I can at least draw my arrow in the direction of where 364 is. So now that I've filled in my table, now I'm going to go through and actually put them on the graph. So -2.0625. Now your -2 is kind of this line out here, and 0.0625 is like barely above the x-axis there. -1 and 0.25 is that one. 0 and 1 is right there. 1 and 4 goes there. 2 and 16 goes there. And then 3 and 64 would be like way up here somewhere. That's not even close. It'd be probably double that. But here's our line. Here's what our line looks like. You want to be really careful here. There's a couple of points that I'm going to make. The first point is my line is going to approach 0. Let's try again. And it's going to increase. On the left-hand side, right here, okay, my line is going to approach 0 but never touch. Okay, so you are never crossing this x-axis, okay? your line is going to level out. If I were to continue going down, if I did 4 to the negative 3 and 4 to the negative 4 and 4 to the negative 5 and so on and so forth, and I continued moving out to the left, my line would look almost flat. It's going to level off as I keep going out. So I'm never crossing the x-axis, okay? The other thing, it's a soft curve here in the middle. There's a curve that increases. It's not a hard U or an L. There's no point in it. It's a curve that's going to turn an increase, okay? So y equals 4 to the x. One of the things that's a common thing for us to find is this y-intercept. The y-intercept is always where x equals 0 in any graph ever. Okay, so look at where x equals 0 and your y-intercept there is 1. Again, some people write this y-intercept as a point. You can write it as 0, 1, or you can just give me the y value. Either one works. Let's take a look at number 2. Now I have y equals 3 to the x. So I'm going to do negative 2, negative 1, 0, 1, 2, 3. I make those the same every time. Okay, that's just my little tip. Name your x values the same every time. Okay. So now get out your calculator and plug those in. So I have y equals 3 to the x. So that means I need to type 3, caret key, and then whatever my x value is, and enter. Okay, so 3 raised to the negative second power is going to be 0.1 repeating. So I've got 0.11 repeating. 3 raised to the negative first power is going to be 0.3 repeating. 3 raised to the 0, we should all know this. Any number raised to the 0 power is 1. 3 raised to the first, oh, excuse me, I'm yawning. 3 raised to the second, we all know 3 squared is 9. 3 raised to the third is going to be 27. Okay, so let's go ahead and put those on our coordinate plane. So negative 2.11, so I come out to negative 2, and 0.11 is barely off the x-axis. Negative 1 and 0.33, a third of the way up to that 1. 0, 1 is right there. 1, 3 is right there. 2, 9 is right there. And then 3, 27. Here's 19. So 27 is going to be like there-ish. Not totally sure. It's off my coordinate plane, clearly. That's the biggest thing to know. And again, remember that that graph does not cross the x-axis. Okay, my line was not straight there in any way, shape, or form, but that's okay. Hopefully you get the point. Again, it turns to the left here and levels out to 0. If I kept going, it would be like a straight line. So this looks like a soft L. There's no hard point in the middle, but it looks like a soft backwards L. My y-intercept is 0, 1 again. You should be seeing a pattern there. All right, let's take a look at number 3. Now I have this added coefficient out front. I have y equals 4 times 2 to the x power. Now, I want to point something out. The only thing that's being raised to the x power is the 2. That's why there's parentheses around that 2. So the 4 is not being raised to x. Do not multiply first. Resist the urge to multiply first. You are not multiplying first here. You have to raise the power first. If you think about PEMDAS, okay, PEMDAS tells you exponents before multiplication and division. So you have to take the exponent first and then multiply by 4. Now, I'm going to start off the same way. I'm going to do negative 2, negative 1, 0, 1, 2, 3 for my x values. I always label mine the same. And then I'm going to go ahead and type those into my calculator. So I'd have 4 times 2, caret key, negative 2, enter. And you can type all that in at one time. That's safe. So 4 times 2 raised to the negative 2 power, and I get 1 there. Okay. Some people like to do it in pieces. If you do 2 raised to the negative 2 power first and then multiply by 4 after, you'll get the same answer. So some people like to do that. They like to do this piece first just in their calculator and then multiply whatever that result is by 4. That works as well. But your calculator knows order of operations. So if you type all this in at once, it's going to do the order of operations for you. So then 4 times 2 raised to the negative 1 power, I get 2 there. 4 times 2 raised to the 0 power, I get 4. 4 times 2 raised to the first power, I get 8. 4 times 2 raised to the second power, I get 16. And then 4 times 2 raised to the third power, I get 32. Okay, so you can kind of see here that our things are doubling. I go from 1 to 2, I double, 2 to 4, I double, 4 to 8, I double. That's because of this factor of 2, because each time you're multiplying that thing by 2 one more time. And you can also all see that they are all multiples of 4. That's because of this coefficient of 4, okay? So that's what happens with those. I mean, 2 and 1 are not multiples of 4, but when you take the 0.2, because these are negative exponents, you had decimals there. And then when you took the decimal and multiplied it by 4, those are the answers you got. All right, so let's put these on the coordinate plane. So negative 2, 1, I come right there. Negative 1, 2 comes up 1. And 0, 4, 1, 8, 2, 16, and then 3, 32 is going to be like way up there somewhere. So you don't exactly see where the graph curves, but you can kind of imagine it is going to curve and then level off to the left, and then on the right, it's increasing. If I look at my y-intercept here, y-intercept is always where x equals 0, so my y-intercept is 4. Or again, you can list that as a coordinate, 0, 4. All right, let's try this one, y equals 6 times 1/2 to the x. So I'm going to start the same, negative 2, negative 1, 0, 1, 2, 3. I'm going to plug this into my calculator. So I have 6 times. Now, for the 1/2, definitely put that in parentheses. So open a parenthesis, type 1 divided by 2, close your parenthesis, then do the caret key, then do the negative 2, then your equals button. So 6 times, I'm going to open my parentheses, 1/2, close my parentheses, raise it to the negative second power. I get 24 there. So then let's try it again. 6 times, open parentheses, 1 divided by 2, close parentheses, raise to the negative first power. I get 12. 6 times, open parentheses, 1 divided by 2, close parentheses, to the 0 power. I get 6. 6 times, 1 divided by 2, raise to the first power. I'm wondering if you can see a pattern yet. I get 3. 6 times 1/2 raised to the second power, I get 1.5. And one more time, 6 times 1/2 raised to the third power, I get 0.75. Okay, so again, you can kind of see a pattern here. I'm at 24, I cut it in half to 12, cut it in half again to 6, cut it in half to 3, cut it in half, cut it in half. And again, that comes from the b value of my equation. That b value tells me what I'm multiplying, or in this case, dividing by. I'm dividing by 2, or in other words, multiplying by 1/2. Basically, you're cutting it in half each time. All right, so now let's put it on the coordinate plane. This one's going to look a little different than the other ones have. So I'm going to start up at negative 2, positive 24, which is like way up here somewhere. Then negative 1, I go to 12. So this is one that is starting high and decreasing. So 6, and then 1, 3, and then 2, 1.5, and 3.75. And I'm going to start up high and come down and level off. Again, your graph never crosses that x-axis, but it will approach it. It's going to approach the x-axis, but it's never going to touch it. My y-intercept here is where the x is 0, it's a 6, or in other words, 0, 6. All right, next one. Ooh, now we have a little bit of a shift here happening. So I have 2 times 3/4 raised to the x power plus 2. So it's almost like I'm going to take my whole graph and shift it up 2 places. That's what that addition of 2 at the end does. It's a vertical shift of 2. All right, so when I start my table, I'm going to start it the same way. -2, -1, 0, 1, 2, 3. And then I'm going to go ahead and plug these in. So I have 2 times, open a parenthesis, 3 divided by 4, close your parentheses, raise it, -2. Make sure you arrow out of your power position there and then add 2. Some of your calculators, depending on what calculator you use, if you're using a graphing calculator, a TI-84, your calculator may put you up into a power position and then you have to hit the right arrow to get back down to the main level. So here I'm going to type this all in. 2 times, open parenthesis, 3 divided by 4, close parenthesis, raise it to the -2 power. Then for me, I'm on a graphing calculator, not a scientific. Many of you are probably on a scientific calculator, but if you're on a graphing calculator, make sure you arrow out of that power. So now I'm back down on the main level, and then I add the 2. This is going to be 5.5 repeating. 5.5 repeating. Hopefully you remember that repetition symbol that goes over the top of a number when it's, or group of numbers when it's being repeated. All right, so now let's do the next one. 2 times, open parentheses, 3 divided by 4, close parentheses, raise it to the negative first, and then plus 2. I get 4.6 repeating. 2 times, 3 divided by 4, raise it to the 0 power, and then add my 2, and I get 4. 2 times 3 divided by 4, raise it to the first power, plus 2, and I get 3.5. This one doesn't have quite as dramatic of a decrease as some other ones that we've seen. Same thing, 2 times 3, open parentheses, 3/4, raised to the second power, and I get 3.125. And then last one, raise it to the third power, I get 2.84. So this one is decreasing, and this is decreasing because of that. The fact that 3/4 is less than 1 is what makes my graph go down. It's what makes my graph decrease. And we're going to learn more about that when we talk about exponential decay. But it's not decreasing a whole ton. The fact that my decrease is only 3/4, it's not that much lower than 1, where it's not going to make a big dramatic difference. Like some of these things were making a big difference. They were growing really quickly or they were decreasing really quickly. This one doesn't have that because the decrease isn't that much less than 1. So if I put these on the coordinate plane, -2, 5.5 is right about there. -1, 4.6 is right about there. 0, 4, 1, 3.5, 2, 3.125, and 3, 2.84. So my graph is going to, let's try that again. I didn't do that very well. Look kind of like this. It's going to approach 2. Because of this vertical shift here, it's not going to approach 0. It's going to approach 2 and stay on that line. And then here, it's going to increase. So this vertical shift just took everything off the x-axis and moved it up 2 places. So that's why my graph is going to approach positive 2 instead of approaching 0. So that's kind of where it levels off. The y-intercept here is where x is 0. My y-intercept is 4. All right, let's talk about the one more of these. So now I have a coefficient out front, but I also have now it's a subtraction, a vertical shift of -1. So I start off the same, -2, -1, 0, 1, 2, 3. And then I'm going to plug in my values. So this would look like 3 times 2 raised to the -2 power, and then -1. Be careful that this is the negative on your calculator and this is the minus sign on your calculator. Those are two different things. One of them's a negative symbol, one of them's a minus sign. So if I plug that in, I've got 3 times 2 caret key, -2. I have to arrow out of mine because it's a graphing calculator, and then -1. I get some negative results here, so I'm at -0.25. Same thing, 3 times 2 raised to the -1 power, -1, and I get positive 0.5. So now I'm back up in the positive part. 3 times 2 raised to the 0 power, -1, and I get 2. And then 3 times 2 raised to the first power, -1, I get 5. 3 times 2 raised to the second power, -1, I get 11. And last one, 3 times 2 raised to the third power, -1, I get 23. So you can kind of see that it almost appears as if they're doubling, but it's one below. Like if we hadn't done this vertical shift, these would have been 3, 6, 12, 24, and you're doubling as you increase, and you started with that 3 because that 3 was your outside coefficient, but then you're multiplying by 2 because 2 is your multiplier. But because of this vertical shift of -1, it's not 3, 6, 12, 24, it's 2, 5, 11, 23. So they're all down 1 because we dropped it down 1. All right, so -2, -0.25 is underneath the x-axis. Yes, you are crossing the x-axis here. You certainly are, because of the vertical shift. So then -1, I'm up at positive 0.5. 0, I'm at 2. 1, I'm at 5. 3, I'm at 11. And then, 2, 11, and then 3 is 23, which is going to be like up here somewhere. Okay, so this is a graph where you're going to approach -1 and level off. So there's my graph. I'm approaching -1 because of the vertical shift that I have happening at the end there. Okay, my y-intercept here is 0, 2. You could also list it as a coordinate either way. And that is my graph. All right, so thanks for tuning into this lesson, and I will catch you next time.